Today we're going to talk about something called conditional probability. So the first thing we're going to look at is called a two-way frequency table. It just means it's displaying two types of data at the same time. All right, so here's one below. It says the table shows data about students' involvement in extracurricular activities at a local high school. What's the probability that a randomly chosen student is a female who is not involved in extracurricular activities? Okay, so really what we're doing is looking at just the females. We're only focusing on the females in this data. So I know there's 259. So I know it's going to be out of 259. The category that I'm interested in is not involved. So not involved, that would be this number right here. So it's going to be 120 out of 259. Our next problem says the table below shows the number of male and female students by grade level on the prom committee. What's the probability that a member of the prom committee is a male who is a junior? Okay, so I'm really focusing on the male category here. Okay, so what's the probability that is male who is a junior? Okay, so I know my total is going to be out of 6. Oops, sorry, I picked the wrong one. I know my total is going to be out of 6, but I'm just focusing on my juniors. So that is 3 out of 6. Okay, so we're really just focusing on specific categories within those tables. So when we talk about conditional probability, it just means that the probability that an event will occur given something already else has happened. Okay, so it's setting parameters, saying this has to be true first. And once that's true, what's the probability of this other event happening? This is how we denote it. Okay, this is our notation. It says the probability of B given A, meaning A has already happened. So what's the probability of something happening given that event A has happened? Okay, so here's our first example. Respondents of a poll were asked whether they were for, against, or had no opinion about a bill before the state legislature that would increase the minimum wage. What is the probability that a randomly selected person is over 60 years old, given that the person has no opinion of the state bill? All right, so the given here, that's the important part. The given is where we really need to start. So given that the person had no opinion on the state bill, that really kind of focuses what we're going to be looking at. So the no opinions is what we want to focus on right here. I'm focusing on this column. So now the question is, what is the probability that a randomly selected person is over 60? So the 40 is that column, right? The over 60. That's the row we're looking at. So it's 40 out of 100. So that given statement, that conditional probability there, focuses our decision making, our pool of data to one specific category. All right, so this is the same data again. What's the probability that a randomly selected person is 30 to 45 years old, given that the person is in favor of the bill? So here's the given that they're in favor. So that's 4 right here. So we went 30 to 45 years old. So we're focusing on the 200 out of 780. All right, for the next one, what is the probability that a randomly selected person is not 18 to 29, given that the person is in favor of the bill? All right, so again, we're looking for in favor, so that's for the bill. Okay, not 18 to 29, so not the 310. I'm looking at everybody else. Okay, so it's still out of 780 because we're still talking about that category, but now I need to add my 200, my 120, and my 150, and that gives me 470. So 470 out of 780. And you can, again, leave those as fractions or put those in decimals. It does not matter. Okay, last one. A company has 150 sales representatives. 2 months after a sales seminar, the company vice president made the table of relative frequencies based on sales results. What is the probability that someone who attended the seminar had an increase in sales? Then we want to know what's the probability that a randomly selected sales rep who did not attend the seminar did not see an increase in sales. Okay, so let's look at the first part here. All right, so it wants to know what's the probability that someone who attended the seminar had an increase in sales. All right, so we're going to know probability of increase in sales given that they attended this seminar. Okay, that's what we're looking for, the probability of an increase in sales given that they attended this seminar. So I'm focusing on they attended the seminar. Okay, and then the specific category is increase in sales. So we're talking about 0.48 divided by 0.8 because that's my total. So if I divide that out, I get 0.6. Okay, the second question says, what is the probability that a randomly selected sales rep who did not attend the seminar did not see an increase in sales? Okay, so they did not attend the seminar. That's our given. So given that they did not attend the seminar, did not see an increase in sales. So no increase in sales. So we're looking at 0.18 divided by 0.2 or 0.20. So when I divide that out, I get 9, oops, I mistyped, I'm sorry. 90, I believe. Yes, 90%. So 90, okay, which makes sense. You didn't go to the seminar, you didn't get help, so you didn't increase your sales. That makes sense, right? 90% of the people who did not attend didn't get any better. Okay, that's what this conditional probability is really trying to focus in on. All right, so I'm going to have you work on your homework. We didn't do this in class activity, so you can ignore that. So just work on your homework, do the best that you can. On Monday, we'll come in and we'll look at things again, and I'll answer any questions that you may have.